Hi everyone, thanks for joining us today. Today we're going to be spending some time on using the EPTS-75A-3 switch for IEC 61000-4-34 testing. During today's video, we're going to begin by walking through the necessary connections to get the system operational. Then we'll move to the calibrations and taking a look at the software. And then finally, we'll go ahead and we'll run a test. For a more general overview on the system, go ahead and check out the other video we made on the EPTS system. The EPTS-75A-3 is fully compliant to IEC 61000-4-34 and IEC 61000-4-11 and is designed for three-phase testing up to 75 amps. It meets all the requirements for testing, including the rise and fall times. This system is limited to a maximum of 480 volts and is only designed for Y power. If delta is used, damage to the unit can occur. Let's go ahead now and let's take a look at the connections needed to get the system operational. Here's the back of the EPTS switch, and below that we have the 3150 AFX. Let's go ahead and let's start from the left and let's work our way right through some of the different connections. In the upper left-hand corner, we have the single-phase input power for the EPTS switch. To the right of that, we have the USB and aux I/O connections. The USB will go to the control computer and the aux I/O connections will go to the digital and analog I/O on the AFX unit with an adapter. You can see that is right next to our black cable, kind of in the middle of the unit. Looking at the top section in the left corner on the back of the AFX, we have the LAN, which will also be going to the control computer. Taking a look now at the top section of our EPTS, working our way right, we have our AC mains input, which will be connected to the AC mains in our facility or our power supply. Next to that, we have the AC source input, which is connected to the green output on our AFX unit. To the right of that, we have our AC output, and that's going to be going to our equipment under test. Finally, in the lower right-hand corner on our AFX unit, we have our three-phase input power. To go over the connections briefly, we have two three-phase power inputs from the facility going to the AFX and EPTS, as well as an additional single-phase connection to the input power on the switch. Let's go ahead now. Let's spend some time on the software and running the test. Here's the test setup tab on the EPTS GUI. There's some criteria that needs to be verified and potentially changed anytime the mains connection or AC source is changed. For our rental customers, this will be when the equipment arrives. As we walk through each, we're referencing the EPTS hardware calibration section of the user manual, which starts on page 79. For a more general overview of the software, go ahead and take a look at the other video we made on the EPTS, which I'll put a link for in the description below. Now taking a look at our test settings section on our test setups tab, we're interested in the lower right-hand corner box for calibration. There we can see we have voltage and phase shift. The voltage measurement calibration is designed to measure the incoming mains voltage on all three phases to be sure it's within the ranges for IEC 61000-4-11 and IEC 61000-4-34. Just below that, we have the phase shift, which calibrates the AC source phase with phase A of the AC mains input. Let's go ahead and let's start with the voltage. To do that, go ahead and be sure that the voltage is selected in the calibration section and then hit calibrate. Here's the voltage calibration menu. We have the mains calibration coefficient on the top and the AC source calibration coefficients on the bottom. For each of the mains input phases, we need to measure the line to neutral voltage using a digital multimeter. With that value, we'll adjust the mains calibration coefficient for each phase to match the displayed voltage on our DMM. We can do the same process with the AC source. However, typically the values shouldn't require much adjustment. Let's take a look right now at our phase A. We're measuring roughly 123.5 volts on our multimeter. So we're going to need to adjust the value of the coefficient so it reflects 123.5, or as close as we can get by selecting the up or down arrows. So let's go ahead and make that adjustment now. Go over to our phase A, and let's go ahead and increase that. All right, and there we are, 123.4. Once we have them all entered and we've made the necessary adjustments to the coefficients, we're going to go ahead and hit the save button. Here's the phase shift, phase offset, and delays calibration menu. We're going to take a look at the AC source phase shift section at the top of the menu. This section has a few different frequency options, with only the selected frequency from the test setup able to be changed. You can see that right now is at 60 Hz. Next to the frequency, you can make adjustments to the phase shift parameter, which will allow for the two phases to be synchronized. Let's go ahead and take a look at some scope traces before and after synchronization. All right, here's our scope trace before the phase shift adjustments, and you can see our two different sine waves aren't synchronized. Let's go ahead, let's make the necessary adjustments using our phase shift parameter, and let's take a look. All right, here's our scope trace with the adjustments made using our phase shift parameters, and you can see our two waveforms are synchronized now, and everything's looking good. Let's go ahead now, take a look at the software again, and run the test for IEC 61000-4-34. Now that we've finished the test setup menu, we're looking to run the test. We're on the dips and interrupts menu now. Let's go ahead and let's click load in the lower right corner. From this menu, we can select the frequency range. We're interested in 60 Hz today. 3-phase. And let's go ahead and let's select the first routine for table 1, class 2 at 60 Hz. All right, as you can see, the criteria loaded in. Let's go ahead and let's run the first step of this routine by unselecting the remaining steps 2 through 4. And now let's go ahead and let's select run. Shortly here, you should see in the lower right hand corner, we're going to see a progress bar shown. And let's go ahead and let's let that progress bar go all the way across, and let's complete the test. All right, so our test just completed, and we have a pop-up now asking if our EUT is functional after the test, and we're to go ahead and select yes. And now we have a list of the different performance criteria. Let's go ahead and let's keep A selected for normal performance, and let's hit OK. One thing you will note is we also have observations below that. We'll go ahead and leave that as none for today as well. All right, now we have a pop-up just letting us know that our test report has been generated. All right, so now let's go ahead and take a look at our test report. To do that, hit the View Report right down there in the center at the bottom, and then select the one that's for today. So let's go ahead and select that one there. All right, so here we have our test report. You can see our test results, test conditions, and test parameters. All right, that should complete the video today on conducting IEC 61000-4-34 testing using the EPTS-75A-3. We began the video by walking through the connections to get the system operational. Then we moved to adjusting criteria and running our calibrations. And then finally, we went ahead and we ran a test. We hope this video has been useful, and please keep us in mind if you ever need to rent the Pacific Power EPTS-75A-3.